You recall today that we talked about surface area within class, and we focused on prisms and a little bit on pyramids in class. And the surface area for a prism, especially a rectangular one, should not be a new feature to you because you did work with those last year in 6th grade, but we just wanted to review the concept so that we could continue to apply it and then further apply it to finding volume of these shapes in the next couple days. So we remember that a prism is classified as a prism by having two ends that are identical, which we identify as bases, and even more so on what we consider the triangular prism, because a common misconception is that we call the base of this a rectangle. And the base is not truly a rectangle, but rather the base is that part of the shape that is identical on at least two ends. And the only part that's identical on two ends for this shape is the triangle on the front here and back. And so the bottom is true. The bottom of this shape is a rectangle down here. But the bases for this shape are triangles. It's going to be very important that we notate that difference when we get to volume. So I'm trying to overemphasize it here as we deal with surface area. So coming back to example number 1. The base is my end down here. And I have two bases. So I'm still going to continue to deal with bases so that we can overemphasize the use of bases. And this base has a length of 6 and a height of 7. So 6 times 7. And we know that we have two of those, so times 2. And as long as you show me all of this work, I'm fine with using a calculator to do the calculations. 6 times 7 times 2 is 84. Now I have a front and a back for a rectangular prism that are going to be identical in surface area. So I'm going to find both of those at the same time. I've highlighted the front. The front has a height of 7 and has a base of 12. And as we said, there were two parts of this rectangular prism that have that same shape. So 7 times 12 times 2 equals 168. So now I have a top and a bottom. Recall again that I said bottom, not base. A top and a bottom that both share the same surface area. And they have a base of 12 and a length of 6. And we have top and bottom would be times 2. That will equal 144. So since I have 1, 2, 3, 4, 5, 6 sides that I have calculated surface area for, and my shape here has 1, 2, 3, 4, 5, 6 sides, we know that we accurately have calculated all of the surface area for this shape. We now just need to add them together. 144 plus 168 plus 84 would equal a total surface area of 396 centimeters squared. Let's see, I'm going to do number 4 because number 4 has something unique about it. Number 4 has already given me the area of a base. In other words, it's identified that the triangular base down here for this triangular prism is 8.8 centimeters squared. If this base is 8.8 centimeters squared, the base on the opposite end of the triangle is also 8.8 centimeters squared. So I'm going to first label my two bases, which is going to equal 8.8 times 2, because I have two bases. Each one is 8.8 centimeters squared. Now I need to start figuring out the area of the other pieces. I have a bottom, which is a rectangular shape, has a length of 4.5, so I'm going to call this bottom. It's 4.5 times, let's see, it appears to be 4.1 centimeters long. And I only have one part of this particular triangle that has that dimension. I have a left side, which is going to be over here. It would also be 4.1 centimeters long. And that left side would be 4.5. And I have a right side, that would be this piece right here, which appears to also be 4.1. And it is 4.5 centimeters in length. So we're noticing 4.1 times 4.5, 4.1 times 4.5, 4.1 times 4.5. This has got to be an equilateral triangle because all three of the sides are equally 4.5 centimeters. So 4.1 times 4.5 is 18.45. And 8.8 times 2 equals 17.6. We add the 18.45 three times because we have three rectangular sides to this triangular prism. And we add the value of our two bases together, which was 17.6. So our grand total is 72.95 centimeters squared. I'm going to do one more shape for you, give you a little bit extra help tonight. This shape is not a prism because I don't have any sides that are opposite each other, directly opposite of each other, that are the same shape. Rather, I have a triangle down here on the bottom. And each of the vertices, the points on the triangle, extend up to a singular point. So we have a triangular pyramid. The base is a triangle, it forms a pyramid. Triangular pyramid. And it already gives us the area of the base. For a triangular pyramid, we're only going to have one base. Prisms have two, pyramids have one. So let's see, I wanted base is equal to 43.3. And now I need to find the area for each one of my sides. Now it appears that each one of my sides has an equal distance on its base, and they are equally tall. So they're 16 meters tall and 10 meters along the bottom. My formula for finding the area of a triangle for my three sides of a triangle that are the same length is 1/2 base times height. I'm going to do 1/2. My base of the triangle is 10. My height of the triangle is 16. And remember that we have three of those that are all that same shape. So 1/2 times 10 times 16 is 80. Times 3 is equal to 240. So the three sides are 80 each, which would give me a surface area of 240. And we add to the 240 the 43.3 from our area of the base, and we get 283.3 meters squared. Hopefully you found these 8 problems fairly easy to do. Most of you that got started on them in class were able to get through quite a few, so you reduced the number of worksheet problems you had for homework, and then just had a few textbook problems to complete before tomorrow. We will go over some questions and answers tomorrow in class. Have a good evening.